Hi guys, and welcome to another preliminary chemistry video in the Chemical Earth series. This one is on the variety of different elements. So we've had a bit of a preliminary look at mixtures and how we separate the components of mixtures, and now we're going to move on to looking at elements and compounds. So specifically elements. Now elements are the important building blocks of matter. They are the basic simplest units of matter outside of things like atoms. But in terms of pure substances, we have 118 different known elements, and each of these combine with each other in order to form compounds. A large number of these elements have actually been artificially synthesized, made in laboratories, and radioactive and unstable. They don't last for very long periods of time. And we also know that when they combine in fixed ratios, they form compounds. So a couple of things that are important to remember about elements. Firstly, they are pure substances. They cannot be decomposed chemically, so they are the smallest units already. All the atoms are identical, or at least similar. We will talk about things like isotopes later on, but they're pretty much identical, certainly in terms of their overall charge. And they have what is very important to us, predictable and testable physical and chemical properties. And it's these that we're actually going to have a look at in a little bit more detail in the next few videos. Now we use chemical symbols as a way of representing elements in a shorthand, because we're going to use chemicals a lot, obviously, in a chemistry course, and we want to try and simplify some of the ways in which we refer to them. Many of the names of the elements were originally Latin forms, and some of the symbols for the elements are based on these Latin names. So, for example, something like the element which was called natrium has the symbol Na, and we now refer to it as sodium. So sodium has a symbol Na, which doesn't really kind of make sense in English, but when you look at the Latin name, then natrium obviously makes a lot of sense. So when the symbols are being used, they will either be 1 or 2 letters, and the first letter is always a capital. So if it's on its own, it will be capital H for hydrogen. If there are 2, then the first one will be capitalized and the second one will be lowercase, as in the case of helium. And you can see some examples on the bottom of that slide. Now the important thing is what happens in the spheres, in the lithosphere particularly, and there are very few elements that are found uncombined on the Earth. Now we know that nitrogen and oxygen are abundant in the atmosphere, above the surface of the Earth. Within the lithosphere itself, though, there's a very small number of uncombined elements, and those uncombined elements are ones that are either very common, such as sulfur produced in volcanic activity, or those precious metals, gold and silver and also platinum, that are in such small quantities and whose properties are so desirable that they are very expensive to purchase and very lucrative if you can find them. Most of the elements, because of the fact that they are chemically reactive, are found as compounds. So if an element is an active substance, if it's very reactive, it will at least combine with something like oxygen in the air or the sulfur and form a compound. And so it's very rare that we find very many elements in their elemental form. We're going to explore some of the properties and uses of elements in the next video. Thanks for watching.